In this video, I'm going to help you to learn how to use graphs to help solve problems. And you should have this is the first question on the multiple choice graphing motion practice. And you should have this interpreting motions graph sheet with you to help you to solve these types of problems. Okay, so first of all, let's look at this problem. It says an astronaut is standing on a platform on the moon, drops a hammer. If the hammer falls 6.0 meters vertically in 2.7 seconds, what is its acceleration? The first instinct that students like to do is to take 6.0 meters and divide it by 2.7 seconds. And they come up with what do they come up with? The 2.2 meters per second. And then they just say, oh, it's B. Well, that's not how you do this problem. That is finding average velocity and not finding the acceleration. We want to find acceleration. Okay? So to find acceleration, we should look at this sheet and find out how we might find acceleration from a graph. And if you notice, the only graph where you're going to find acceleration is from the velocity versus time graph. Okay? So the slope on the velocity versus time graph will give us the acceleration. So if we construct the velocity versus time graph, we can find the slope on that, and that would give us our answer. All right, now you don't really have to be particular in making this. Just label a set of axes with their units. Okay. Velocity versus time graph is the most commonly used graph to solve these types of problems because it has so much information on it. We can find the slope, the acceleration, but we also can find displacement from an area under the curve. So it's actually two pieces of information. Okay, so what's actually happening in this problem? Well, we got a hammer, which I'm just going to represent by a circle because I'm not drawing a hammer. And let's say this is at time 0. All right, this is 0 seconds before it's dropped. It's not moving at all. In fact, its velocity at this point, velocity at 0, is also 0 meters per second. So that would give us a point on our graph, which would be 0 times 0 meters per second. It's going to accelerate at some rate, and at a later time, we're going to call this time 1. Time 1 is going to be just 2.7 seconds, and it will have some velocity, which we don't know what that is actually at this point. We also know that the displacement, first of all, it's displaced at the beginning. Displacement 0 would be 0 meters. Displacement 1 at this point would be 6 meters, right? We have traveled 6 meters down. And we're choosing the downward, in this particular case, as positive direction. Okay, so what information do we have that we can start to construct this velocity versus time graph? We know that we want to find the slope, because the slope is equal to the acceleration based on this right here, right? The slope on the velocity versus time graph is the acceleration. So that's our total goal. So we know that at sometime in the future, at 2.7 seconds, we know that we will have some type of velocity. We don't know exactly what that velocity is, but we also know that this will accelerate at a constant rate. And accelerating at a constant rate means that our slope on the velocity versus time graph must be constant. Okay, so that's because the slope on the velocity versus time graph is the acceleration, and if acceleration is constant, that means the slope cannot change. Right, and this slope is not changing. We're going to say that this is velocity 1, which we have no idea what that is yet. Okay, now what other information do we know that we can use on this velocity versus time graph? I'd encourage you to look at this chart and try to figure that out. What other information do we know from the problem that is a feature on this velocity versus time graph? I would suggest you pause this video and try to figure that out, and I'll tell you what the answer is in a couple seconds. Okay, so the information that we have is that the displacement is 6 meters. Okay, and if we go to this sheet again, we see that the area under the velocity versus time graph is the displacement. So that means that the area up to 2.7, the area under this graph right here, this, I'm using too dark of a color. Let me use a lighter color. This area right here is the displacement. Well, what is the displacement? It's 6 meters. So this area is 6 meters. Okay? Now, since we know that area is 6 meters, and it's weird to have an area as 6 meters, not meters squared, but because our axes are meters per second and seconds, the seconds cancel out and we just get meters. But since we know this area is 6 meters, and we know that the base, right, the base is 2.7 seconds, we can find what this height is, right, this vertical height. It's V1. So what is V1? So you should pause this video again and calculate what that V1 is. Okay, now I'm going to tell you how to calculate V1. We know that the area of a triangle is 1/2 base times its height. Well, we know what the base is. It's 2.7, right? The base is 2.7 seconds. The height is what we're looking for, and we know that the area is 6 meters. So if we solve for the height, which is actually our V1, then we will get 4.4 meters per second. That is what our V1 is, 4.4 meters per second. Okay? Now, that's just our final velocity. That's the velocity that we have at V1. So it's 4.4 meters per second. This does not tell us what our slope is. Remember, our whole goal is to find the slope, which will give us the acceleration. Okay? So, from all the information that I've provided, what is the slope? You should be able to calculate the slope now. Go ahead and do that. Pause the video again. As you know, the slope equation is the change in y over the change in x, or in this case, it's the change in velocity over the change in time. And the change in velocity is 4.4 meters per second minus 0 meters per second, right, which seems a little silly, and 2.7 seconds is our change in the horizontal minus 0 seconds, again a little silly, and that will give us a final answer of 1.6 meters per second squared. And this is our final answer to the problem, and so it is 1.6 meters per second squared, or option A. Hope this has been helpful. Goodbye.